Okay, so we're going to have a go at doing another example of a tangent and a normal. And we're going to use a trig curve at this stage. So let's have a look at the curve of y equals sine x. And we're going to find what's going on at the point, so this is pi over 2, because we're big folks now, we're going to work in radians. So this one we'll call pi over 6. So we're trying to find out what's the tangent and the normal to the curve y equals sine x at the point x equals pi over 6. Okay, so that's the language. We're trying to find the tangent and the normal to the curve y equals sine x at the point x equals pi upon 6. So let's have a look at the point. At the point x equals pi upon 6, y will be sine pi upon 6, which is about 0.5, exactly 0.5. Okay, so that's exactly 0.5, so the y value is 0.5 when x up pi upon 6. So the point is pi over 6, 0.5. Okay, so that's the actual point we're working at here. Pi upon 6, 0.5. And we're going to try and find the tangent to that point. Okay, so the first thing we need is the slope. So the slope of the tangent is dy by dx evaluated at the point where x equals pi upon 6. Here, dy by dx is the derivative of sine x is cos x, and at x equals pi upon 6, dy by dx is equal to cos pi upon 6, which is root 3 over 2, which is a decimal is 0.866, I think. Yep, I'm pretty sure that's right. Okay, so we could use that as a third, root 3 over 2, but let's go with the decimal. So now we have a point and we have a slope, which enables us to work out the y-intercept. So we remember y equals mx plus c, as we were heading for. So c is y minus mx. Y is 0.5 minus the slope, 0.866, times x, pi over 6. Get an answer for that, which is probably going to require pushing some buttons on the calculator. We could do it otherwise, but 0.5 minus 0.866 times pi over 6 equals 0.047. Okay, so that's our value for the y-intercept. So the tangent is y equals m x plus c. And that's the equation of the tangent, which makes sense in this case. It looks about right. If we put tangent on this curve, something like that. So it's going through a small number down here. So that looks about right for that value. And it's got a slope, which we're trying to say is about 0.866. So that's the slope going up this way, is what we're looking for. And then we need to find the equation of the normal. Okay, stop that. Okay, so the equation of the normal, so remember the critical thing for the normal is that the slope of the normal is -1 over the slope of the tangent. So in this case, it's -1 divided by 0.866. And we can get a calculator out and do that. -1 divided by 0.866 is -1.15. Okay, so that gives us the slope of the normal. We've got a point. we've got a slope, so we should be able to work out where the intercept is. So we go through exactly the same process as we did before. Y equals mx plus c, rearrange. C is y minus mx, y 0.5 minus m times x, pi over 6. Push some buttons on the calculator. So we've got 0.5 minus negative, it'll be a plus. Oops, I got that wrong. Plus 1.15 times pi divided by 6 gives us 1.10. So the normal is y equals m x plus c. Okay? And that gives us the equation of the normal. And again, that looks to be about right. If we go down there, we've got a slope which is negative, and the point up here, well, my scale's not great. This is 1, so it's a wee bit bigger than 1, so it doesn't look too bad. So we have the equation of the tangent, and we have the equation of the normal. Remembering that both are equations. Okay, so for each of them, you've got to work out the slope, and you've got to work out the intercept, and then you put them into that equation, into the form of an equation of a line to get the answer to the question. Tangents and normals.